All right, let's get right into it. We're looking at one of the biggest problems in all of science. See, we have two incredible theories that explain our universe, but here's the catch. They absolutely hate each other. They just don't work together. So, what's the solution? Well, today we're diving into two completely different answers, a real tale of two universes. So, let's start with, the biggest question you can possibly ask. What is the universe actually made of? Is it a bunch of tiny little particles zipping around on a cosmic stage we call spacetime? Or is it something way, way stranger? For the better part of 100 years, this question has had physicists completely stumped. The rulebooks we have are amazing, but they contradict each other. So today, we're going to put two of the leading and totally different answers head to head. And this whole mess, it has a name: the quest for quantum gravity. And honestly, it's probably the single biggest unsolved problem in physics today. It's the hunt for one single, elegant theory that can finally describe, well, everything. So what's the hang-up? Well, on one side, you've got Einstein's general relativity. It describes gravity as this beautiful, smooth, flowing fabric of space-time. But on the other side, you have quantum mechanics, which says the tiny world of particles is a buzzing, chaotic place where everything comes in little packets, or quanta. They just don't speak the same language at all. So in one corner, we have what you might call the reigning champion. It's a theory called asymptotic safety. And its whole game plan is to take the crazy, infinite numbers that pop up in our equations and tame them. Asymptotic safety, or AS for short, doesn't want to tear up the old physics textbooks. Instead, it suggests that when you crank the energy way, way up, like inside a black hole, gravity's strength doesn't just spiral out of control to infinity like our current math suggests. Nope. It hits a kind of ceiling, a fixed point, and just levels off. That makes the whole theory predictable and, well, safe. So how does it pull this off? Well, think of it like this. Down here, at normal energies, gravity's pretty simple. But as you zoom into smaller and smaller scales, quantum weirdness takes over, and the mass just explodes. AS says there's this magic spot, a fixed point, where gravity's behavior just chills out. It stops growing, and suddenly the math works everywhere. The chaos is tame. And in the other corner, we've got a radical newcomer, a real challenger. It's called dynamic vacuum field theory. And this idea doesn't just want to tame gravity. It wants to completely rewrite what we think the universe is. It pictures everything as a kind of cosmic ocean. Now, this one is a trip. Dynamic vacuum field theory, or DVFT, says there is no such thing as empty space. Period. The entire universe, it claims, is one single physical substance. And everything, you, me, the stars, the forces holding it all together, we're all just different kinds of ripples and waves in this one fundamental medium. So in this cosmic ocean picture, gravity isn't some fundamental force. It's just an effect of changes in the medium's density, kind of like deep, slow currents in the water. And all that quantum weirdness, that's more like the tiny, fast ripples on the surface. The real kicker here is you don't need to quantize gravity at all. It's all just the natural behavior of this one underlying field. Okay, so you see what we're dealing with here. We have our two contenders. One is a careful extension of the physics we already know, and the other is a complete top-to-bottom reimagining of reality. So let's put them side by side and really see how they stack up. First things first, what do they say reality even is? Asymptotic safety is, the conservative one. It says reality is pretty much what we already think, a space-time stage with quantum fields acting on it. Dynamic vacuum is the radical. It says no, reality is one single physical substance, and both space-time and the fields are just illusions that emerge from it. And the tools they use couldn't be more different. Asymptotic safety uses this incredibly complex, heavy-duty mathematical machinery called the renormalisation group to figure out how physics changes at different scales. Dynamic vacuum, on the other hand, uses much simpler classical math, the kind of equations you'd use to describe waves moving through water. This all leads to completely different plans for creating that theory of everything. AS is trying to find those special mathematical points where gravity and all the other particles can finally meet up and play nicely together. But for DVFT, unification is already baked in from the start. Gravity and the other forces aren't separate things you have to join together. They're just different moods of the exact same underlying field. So let's look at the tail of the tape. For asymptotic safety, the goal is to quantize gravity. For dynamic vacuum, it's to have gravity emerge. For AS, reality is field living on spacetime. For DVFT, it's one single medium. The math is super complex versus elegantly simple. And the nature of the whole project, it's a careful extension versus a complete redefinition. I mean, you couldn't get more different.
Okay, but talk is cheap, right? How do we actually put these theories to the test? Well, one of the classic hurdles that any theory of quantum gravity has to clear is calculating the entropy of a black hole, basically a measure of all the information it's hiding.
And this is where it gets really fascinating. They can both do it. Both theories can calculate the correct answer, the famous Bekenstein-Hawking formula. But the way they get there, oh man, it's like they're coming from two totally different planets, which just goes to show you how deep this philosophical divide really runs. So with all that in mind, let's break out the scorecards. Let's really judge this bout. What are the pros and cons for each of these contenders right now? Looking at the scorecard, for asymptotic safety, its big strength is that it's mathematically tough as nails, and it's built on ideas we already know and trust. The weakness? It still has to rely on some approximations, and it hasn't quite managed to unite everything just yet. For dynamic vacuum, its strength is its stunning simplicity, and the fact that it's unified from day one. Its weakness? It's the new kid on the block, and it just hasn't been fleshed out with the same mathematical muscle as its rival. And all of this brings us right back to that final massive question. A question that's maybe less about math and more about the very nature of what it means to exist. What is reality? Really? When you boil it all down, the choice between these two ideas is about a deep philosophical divide. Is our universe at its core just a set of abstract mathematical rules, or is it made of actual, tangible stuff? A physical substance whose behavior just happens to create the rules we see. So we're left with these two incredible visions. A universe that's basically math all the way down, or a universe that's a tangible cosmic medium. Which one is right? Well, that's what future experiments will hopefully tell us. But for now, I'll just leave you with this. Which one of those visions of reality feels more compelling to you?